Okay, dear students, so now today's class I am going to discuss on Townsend theory, comes under gaseous dielectrics, module 1, high voltage engineering. Okay, so already I have discussed here in gaseous dielectric its properties, types of collision, primary, secondary. Using that concept, let us go for, okay. So now what is there here, what already we have analyzed the ionization of collision, what is takes place, it applicable for primary and secondary ionization. So here we are going to study the derivations of primary and secondary, important derivation, every time question paper it has been asked. The first ionization coefficient here, alpha we are taking here, it is defined as the average number of ionizing collisions made by electrons per centimeter travel in the direction of the field. Alpha depends upon pressure as well as electric field, and alpha proportional to what here? So alpha proportional to E by P. Okay. So now let us consider a parallel plate capacitor having a, so here we are considering two plates, one is cathode and there is what, anode, and source I am applying for this electrode which is immersed in a gaseous dielectric, and cathode, when source is applied, voltage is applied, what happens, and it is applied by distance. Here we are maintaining distance also, this is the distance we are maintaining. Okay. So now here what happens, and number of electrons emitted from the cathode, when one electrons collide with neutral particle whatever exists here, so what happens, positive ions and electrons are formed here in this condition. When voltage is applied to the cathode, so what happens, because of neutral molecules present here, so it will combine with this neutral particle, one electron collide with neutral particle and positive ion electrons are formed again. Okay, and this process is nothing but ionization by collision. So now, and alpha is the average number of ionizing collision made by the electrons per centimeter. See, cathode anode anta aiti. Okay. So now this distance we are considering E, and D is the distance, and X we are taking a particular part of that in between anode and cathode. Okay. So now alpha be the average number of ionizing collision takes place. Okay. So now with this see, so in this breakdown process of gases takes place here in three regions we are going to discuss. One is ohmic region, another is saturation region, and there is Townsend discharge region. What is this actually ohmic region? Okay, you can see here in this, it is observed that current at first starting itself, once collision starts, what happens, current increases proportionally with increase in the field or voltage. Whatever voltage applied, current increases, that is ohmic region. Okay, and this region is ohmic region. After this state what happens, the current become constant here. Okay, even though voltage is increased, current become constant, so that is nothing but saturation current. At still higher if you take, that is current exponential Townsend discharge region here. Okay. So this is the current growth in Townsend discharge. Using this, let us go for derivation. This is very important, almost a question paper it has been asked. That is, derive the expression of current in that is primary ionization coefficient. Okay, this is the Townsend current growth equation, and N is the number of electrons emitted from the cathode. Okay, so this is the number of electrons emitted from the cathode. Okay, and if one electron collide with neutral particle, so what happens, positive ion electrons get formed. Okay, average number of electrons here, E by P I am taking here, gas pressure as well as field I am considering. Let us see, Nx is the electrons here, and further distance dx give rise to A Nx dx, alpha anta baribodu now. Okay, so now just I will take here, first I will consider distance x equals to 0 and x equals to n naught. Okay, I am taking the condition at particular condition, electrons and all. So if you do differentiation, so d nx by dx, the A alpha nx anta barutta. So do differentiation, it will be Nx is equals to n naught exponential alpha x. Okay. Number of electrons reaching the anode, from cathode to anode, if it will reach, it will take distance x equals to d. So therefore Nd is equals to n naught exponential alpha d. Okay. So Nd is equals to n naught exponential alpha d. Okay. Exponential alpha d. So from this you have to get it, what is exponential alpha d. So therefore Nd minus n naught by n naught. So therefore final equation we are getting, I is equals to I naught exponential alpha d. This is the main equation. This is very important for exam point of view and problem also. Using this I is equals to I naught exponential alpha d. So here problems are there on particular first ionization coefficient, simple problem they have given. Okay, steady state, the current also they have specified, distance value they have given, and then what is the distance, once what happens, whenever field remain constant, the reduced distance will be 0.1 centimeter, it current of 5.5. Okay, all values they have given, d1, d2, two distance they have given, first distance will be 0.4, okay, steady state, and field constant d2 will be 0.1, and current I1, I2 they have specified here, initial final current I1, I2, Okay, and you have to find here using this equation I1 I2 is equals to exponential alpha d1 minus d2, because 2 we are taking. Okay, if you compare 2 means 2 we have to take I1 I2. So then I1 I2 if you do, it will be 10. So from that alpha value you have to get it. Okay, same you have to go for another problem. So this is from Vadva book. Same problem, all values they have specified, steady state current, and then distance they have given, voltage they have given, Townsend first ionization coefficient. Okay, everything they have specified over here. Okay, same problem, everything little bit value it is changed. Okay, so now and just you have to apply I is equals to I naught e raised to alpha x, substitute here the value they have specified here, I naught is there, and from this you have to get it, actually you have to get it alpha value from this. They told here determine Townsend first ionization coefficient andre alpha value ತೆಗಿಬೇಕಾಗುತ್ತೆ. All values are specified, and this is the first ionization coefficient I is equals to I naught e raised to alpha x. Substitute you will be getting. Okay, this is all of first ionization coefficient. Now we'll go for second one, current growth in secondary. Secondary andre once voltage is applied, and what happens once the positive and electrons will form, again it will go towards anode. Okay, so ಇಲ್ಲಿ diagram ಐತೆ ನೋಡ್ರಿ, ಇದ್ಲೇನಾಗುತ್ತೆ, if it will go towards anode, those electrons whatever this ions will be there, if go towards anode, again secondary process will takes place. Okay, secondary process will takes place. So single avalanche ಅಂತೀವಿ ನಾವು, and sometimes they may ask condition of spark, you have to specify here. A single avalanche process will takes place in the previous section. So now what happens, it will multiply. The probability of amplification of electrons will takes place, which will give rise to the mechanism. So what happens here, main thing what will takes place, when positive ion released from the sufficient energy from this cathode, what happens, so again it will impose the continuous process, electrons will takes place, whatever the excited atoms or molecules in the avalanche process will be there, again it will emit photons, and again it leads to the emission of electrons and all. So whatever the metastable particles will be there in that, what happens, it will diffuse back and collision process will takes place again. Again the electrons produced by this process, secondary process, metastable atoms, that is secondary electrons. Before it was primary, now it is secondary electrons. Okay, now total number of y is the sum of the individual coefficients will be take y1 y2 y3. This is the Townsend secondary ionization coefficient, it's a function of all the gases, and pressure P and E by P also it is, and different we are taking here Townsend secondary ionization 1 2 3. And current how it actually takes place in Townsend process, in this I am taking, before it was taking n naught dash is the secondary electron produced by the secondary process, that is gamma. N naught double dash is the total number of electrons you are getting from cathode electrode. Okay, total number of electrons will be n naught plus n naught. So total number of electrons n is equals to n naught dash exponential alpha d. Before it was n naught, now it is double dash, combined it is n naught plus n naught dash. This is n naught dash, actually dash is missing. Okay, so substitute here, and n naught dash what is gamma n minus n naught plus n naught dash. Okay, gamma you take it in this condition. So n naught dash, what is n naught dash, this is the formula we are taking here, and from this n we are finding, this is the equation we are getting for what, secondary ionization. I is equals to I naught exponential x bar d for primary. Below we are getting extra, that is secondary 1 minus gamma exponential alpha d minus 1. So two derivations are very important, almost a question paper it has been asked, primary coefficient and secondary coefficient. Once we get this, sometime the condition they told, what are the conditions for spark. So the equation togori, in this equation just I am equating, alpha is the Townsend first ionization, gamma is the second ionization, d is the distance length of electrons. From this equation you take it, I will be equating 0, that is equals to 1 if e raised to alpha d greater than 1. So now I am taking different condition. If gamma alpha d is equals to 1, in this condition what happens? So in this condition if it is equals to 1, what happens? So what happens here, discharge is said to be self-sustained antiv now, condition kedidaru. And if it is greater than 1, ionization produced by the successive avalanche is cumulative process, more rapidly. Okay, and if it is less than 1, if you consider not self-sustained, removal of source, current I naught only remain constant in this condition. Kedidaru. So explain secondary primary ionization and also condition of spark. Okay, so once we go through all those things, sometimes they may ask what is the limitation of Townsend theory. So actually in this drawbacks will be there. What is first drawback of Townsend theory? Actually here it actually this current growth will takes place due to result of ionization process, as we know. But actual practice if you see, It depends upon gas pressure and geometry of gap. Second ionization, if you see, it will predict the time lag of order of 10 raised to minus 5 seconds. But actually, it is short period will be the 10 raised to minus 8. And Townsend mechanism, if you predict, varies diffuse from discharge, but it is actually it is filament and irregular will be there. It is applicable for PD and value between 1000 torr centimeter. And whatever we are getting limitations of this Townsend theory, same thing it will act as advantage over streamer's theory, as what I am going to discuss next. Okay. And same thing, actually these are all important, and same the Townsend criteria for breakdown ಅಂತ ಕೇಳಿದ್ದಾರೆ, equations ಅಷ್ಟೇ ತಗೊಂಡಿದ್ದಾರೆ ಇಲ್ಲಿ. Okay. And sometime they may ask coefficients of alpha and gamma ನು ತೆಗೆಯಂದಿದ್ದಾರೆ. So just with the diagram they have explained, that you can read for main exam. Okay, with the diagram they explained, that is there. Okay, and sometime they may ask what is that breakdown in electronegative gases. Sometime the questions write a note on. Okay, so that I am going to discuss. Okay, electronegative gases andre Paschen's law, what is time lag. So questions ಕೇಳಿದ್ದಾರೆ exam ಅಲ್ಲಿ. Okay, that I am going to discuss next.